Hello all, this is Taras here recording solution to exercise 13. So this is what we would have been doing in class today if we would have not had a snow day. I'm a little bit sick, so you get to hear my deep radio voice. And hold on a sec, we were just here. Apologize for coughing occasionally. Oh yeah, first of all, I wanted to start with so this is page 45. So make sure you read through this. And the key is that, again, we have one categorical, one measurement variable. So that means we are comparing means. And that's what it says right there. Okay, so that's the key to this. And we did an exercise, exercise 12. So make sure to review that before you start this. And we're going to be looking at a table in which we're going to be comparing means, but we're given other information here. Standard deviation, minimum, maximum, because the marks variable, so this is mean mark, is a measurement variable. So you can calculate the mean, standard deviation, the minimum, maximum, and all kinds of other statistics for the distribution. And so we'll be comparing school A to school B. Mean mark, mean mark. Okay, and there's three different calculations you're going to learn how to do today. The first is raw difference. That's here. Percent difference. So both of these you've done already in the Math 11-12 course. And then Cohen's D is the only new one. All right, and these are, so this is very straightforward, just mean 1 minus mean 2. This is mean 1 minus mean 2 divided by the second mean, or whichever one is lower, usually. So you're comparing mean 1 to mean 2 if mean 1 is higher, like in the example here. Or mean 2 to mean 1 if mean 2 is higher. Exercise 13. The research question is: a teaching of math in school A more effective than in school B? And I'm expecting that you've read the preamble. I'm not going to read all that for you. Do students from school A score higher on a math test than school B? So that's our more effective, is score higher on a math test. Those are, we're using them as replacement. Independent variable will always be the categorical. Sorry about that. I just selected the whole thing. Categorical. And dependent variable will be measurement. So here, school, and then mark on test. And so we're going to look at various marking schemes and various situations to help us tease out what practical difference could mean in with categorical measurement variable. So here we have school 1 versus school 2. You'll note that this looks like the regular kind of thing, right? Because we have marks of 77, 71. And here we have something different going on, study 3 and study 4. So we look here, this is a test out of 100. Okay, so that's what this looks like. And study 3 and study 4, test out of 20. So we're showing two different types of situations, and where we have different values for standard deviations, we have differences here that are not consistent, and so on. So let's look at all. So it'll be 4 situations, 4 studies of the same idea, same topic. Study 1, students in school A, the mean scores were 2.2 marks higher, right? So that's 74.3 minus 72.1. And here we have 6.2 marks higher. Here we have 2.2 marks higher, and here we have 6.2 marks higher. So you can see that we have 2.2 and 2.2 versus 6.2 and 6.2, right? So I've designed these to get specific values. That should be 72:72.1. All right. Those are straightforward calculations, but they're leading us towards something. Maximum mark achieved was different in the different studies. Raw differences alone doesn't help answer the research question. What was the research question? Is a teaching method at school A more effective than in school B? Are school math marks on a test higher in school A than school B? Okay, so a difference of 2.2 in the first one is not the same, so in study 1 is not the same as a difference of 2.2 in study 3, and we'll see how. So at what point, the question I'm asking here, this is the practical significance issue. At what point are raw differences worth announcing and publishing and saying, hooray, I found something? And that's a tricky thing. Sorry, I jumped way ahead here. I got to learn to scroll more slowly. Exercise 13, calculating practical significance for comparison. Study 2, the raw difference between means 6.2 is much higher than study 1, right? So we got that from this here, right? Study 2, we got 6.2, study 1, 2.2. So there's a higher difference, but it's a much more dramatic difference because the mark is out of 20. So 6.2 out of 20 is not the same as 6.2 out of 100. That's the point I'm making here. So what we're going to do here is instead, I filled in the table for the raw difference, right? This is mu1 minus mu2. And now we're doing mu1 minus mu2 over mu2 times 100 to get this percent. And then I want you to calculate these percentages. And I'll pause it here. So we have here, so to speak, a blank slate. And I will be filling in these numbers slowly. So I'd like you to pause it as you calculate each one. And I'll just talk a little bit about where those numbers come from. So the first solution here is 8.7%. So basically I took 6.2, which is a difference between these two numbers, and I divided by, sorry, not by those two. Erase that. Difference between these two numbers, and I divided by the lowest number. That's mu2. Okay, and then multiplied by 100. In the same way, like here I get 18.2%. And here, understandably, I get a much higher value, 54.87%, because this is 6.2 divided by 11. This is 2.2 divided by 12. This 6.2 is divided by 71, so we get a smaller percent difference. Cohen's d, all you do is you divide by, this is sigma, oops, bad sigma, it's more like a delta, sigma pooled. Okay, it's the combination of the two. And so the values I get here are 0.579. Interestingly, 0.579. I hope these are all correct. And 1.676. So again, this value, the difference of 6.2 is the most practically significant from each point of view. As a raw difference, 6.2, because the max marks is 20. As a percent difference, it's the largest. And now the question for you is, which would you consider to be the most practically significant? And so you could look at, I would focus on the raw differences and the percent differences because those are meaningful to you. The Cohen's d, not so much. So some of the answers will be clear, some won't, but that's worth discussing when we get back together. And that's a kind of a deconstruction or explanation or discussion a little bit of exercise 13 for you. I hope it helps.